Hi, welcome to science class. Today, I will explain the basic concepts and principles of dissolution. When salt dissolves in water, a substance like salt is called a solute, and a substance that dissolves other substances like water is called a solvent. And the salt water making in this way is the solution. The solution is a mixture of two or more pure substances and exists homogeneously as if it were not a mixture. The solute dissolving in a solvent to become a solution is called solvation and is commonly called dissolution. The naked eye hardly distinguishes the final salt water without tasting it. But what's clear is that the solid salt dissolved in this cup. How did the solid salt disappear from our eyes and become solvated when we didn't even heat it to liquefy it? Salt, commonly used in cooking, has crystals. If you look closely at the crystal, it consists of an electrostatic attraction of a larger green sphere of chlorine anion and a relatively little blue sphere of sodium cation. Let's dissolve salt in water. The chemical formula for water is H2O. It is covalently bonded to two hydrogen atoms on both sides at a bonding angle of 104.5 degrees, with one oxygen atom at the center. Oxygen, which shares electrons but has a more potent pull force, has a partial negative charge, and hydrogen atoms deprived of electrons have a partially positive one. The force that oxygen pulls hydrogen's electrons is strong, so a powerful intermolecular attraction acts with adjacent water molecules, called hydrogen bond. Let's take a closer look at the melting process. Water molecules can separate sodium cations and chloride anions from the solid state, because they are surrounded by water, a solvent. Strictly speaking, this is possible because the attraction between a solvent and a solute is greater than or equal to the attraction between a sodium cation and a chlorine anion or water molecules. In this way, water is a solvent expressed as hydration rather than the term solvation. Previously, we discussed that water, a polar molecule, and salt, an ionic bond, are dissolved well with each other. So, how do nonpolar molecules dissolve? Likes dissolve likes. Polar molecules dissolve polar molecules. Nonpolar molecules dissolve nonpolar molecules. The nonpolar molecules melt into the nonpolar solvent, between which only the London dispersion force acts between molecules. The London dispersion force is a force of a different nature from hydrogen bonds in which a distinctly strong polarity is expressed, making it difficult to dissolve with water. It is easy to nonpolar bond molecules bonded by the London dispersion force. Thus, nonpolar molecules bind to nonpolar solvents and become disordered, increasing entropy. Let's talk about entropy in detail next time. Anyway, if you look at the separation of water and oil in the cup, let's think about it this way. London dispersion forces bind oil, and hydrogen bonds bind water. So oil cannot combine water because of the different characteristics of the forces. Usually, hydrogen bonds are strong intermolecular attractions, so I think they don't mix well with oil, which is false. Usually, palm oil has a boiling point of 300 degrees Celsius, and water has a boiling point of 100 degrees Celsius, so the intermolecular attraction of palm oil is larger than that of hydrogen-bonded water. In other words, dissolution is not achieved by the strength of the force, and dissolution is easy when the characteristics of the force are similar. Here we need to point out two important things about melting. First, to dissolve and stabilize, the attraction between solute and solvent has to be larger than between solute and solute or between solvent and solvent, which is a basis of dissolution. Secondly, the characteristics of forces between molecules must be somewhat similar. Regardless of the strength of the force, the dipole-dipole forces can blend well with hydrogen bonds, but let's know that the London dispersion power is difficult to mix well. If solvent and solute are in a liquid state, which is solute and which is solvent? In other words, vinegar dissolves well in water. But does vinegar dissolve well in water, or does water dissolve well in vinegar? Both are in a liquid state, so the solvent and solute are determined by the amount. A more enormous amount is a solvent, and a smaller amount is a solute. And does the term solution refer only to when the solvent is in a liquid state? No. To begin with, the air is a solution, and brass is a solution. Air and brass look homogeneous, as if they are made up of a single pure substance, but they are mixtures. Air uses about 78% of nitrogen as a solvent, and gas molecules such as oxygen, argon, and carbon dioxide are dissolved as solutes. The same is true of brass. It varies depending on the ratio of copper to zinc, but copper is 65% and zinc 35% in general, and zinc, a solute, is dissolved in copper as a solvent. Thank you for watching the video until the end, and if the video was helpful, please subscribe, like, and hit the notification bell. This is the science class.